Above the silent curve of the Earth, where darkness meets the thin glow of atmosphere, thousands of machines move in disciplined paths. They do not collide. They do not panic. They follow an invisible order, an order that resembles a quiet system of traffic lights in space. We often imagine space as empty, but it is no longer a lonely place. Satellites circle the planet in carefully planned orbits, each with a purpose: communication, navigation, weather, security. As their numbers grow, so does the risk of chaos. One mistake, one collision, could create a chain reaction of debris, turning useful orbits into dangerous fields of fragments. And yet, this does not happen. Why? Because there is awareness before action. On Earth, traffic lights control movement through clear signals: stop, go, wait. In orbit, there are no glowing lights, but there are systems that serve the same purpose. These systems track every object, active satellites, and even the smallest fragments of debris. They calculate paths, predict future positions, and quietly warn when two objects may come too close. This is called conjunction assessment, but at its heart, it is simply mindful observation. When a risk is detected, a decision is made. A satellite may adjust its path slightly, just a small shift, a gentle correction. Not a reaction of fear, but a response of understanding. This is how harmony is maintained, not through force, but through awareness and timely action. Consider this: in space there are no traffic jams, no honking horns, no visible signals. Yet there is order. This teaches us something deeper. True control does not always need to be seen. It exists in preparation, in quiet calculation, in the willingness to move when movement is needed, and to remain still when stillness is wise. These space traffic lights are not physical objects, but a network of data, cooperation, and discipline. Nations and organizations share information because in orbit no one operates alone. One satellite's mistake can affect many, so there is a shared responsibility, a collective awareness that transcends borders. And here lies the lesson: safety is not created at the moment of danger. It is created long before, in the calm observation of patterns, in the respect for space and movement, in the humility to adjust course. The satellites do not compete for space. They coexist within it. They follow paths, but they are not rigid. When the moment calls, they adapt. This balance between structure and flexibility is what keeps them safe. In a world that often rushes forward without pause, the silent discipline of orbit offers a different approach. Watch carefully, move wisely, adjust when needed, and trust that order can exist even in the vastness of the unknown. So above us, in that quiet expanse, there are no red or green lights, yet everything flows, not because it is controlled by force, but because it is guided by awareness. Space is no longer empty. Thousands of satellites orbit Earth, making space crowded and increasing the risk of collisions. Space was once imagined as a vast emptiness, a silent ocean where only a few explorers drifted without concern for others. That vision no longer reflects reality. Today, the region surrounding Earth is filled with motion, intention, and increasing density. Thousands of satellites now circle the planet in carefully chosen paths, each serving a specific purpose: carrying signals, observing weather patterns, guiding navigation, and supporting global communication. What once felt infinite is now becoming structured, and in certain regions, surprisingly crowded. This growing presence introduces a quiet tension. Every satellite occupies space, moves at incredible speed, and follows an orbital path that may intersect with others. Even a small object traveling so fast carries the potential for destruction. A single collision does not remain a single event. It can create countless fragments, each becoming a new threat. Over time, this could lead to a cascade effect, where collisions generate debris that triggers further collisions, slowly turning useful orbital paths into dangerous zones. Yet, despite this rising complexity, order persists. The movement above us does not descend into chaos. Instead, it reveals a subtle discipline shaped by human foresight. Each satellite is placed with care, its path calculated with precision, its behavior continuously observed. The sky has not become crowded in a reckless way. It has become organized, though the organization is not visible to the eye. This transformation from emptiness to structured activity reflects a deeper shift. Space is no longer just a place to explore. It is a shared environment that must be managed with awareness. The growing number of satellites demands responsibility, patience, and coordination. It reminds us that expansion without mindfulness leads to risk, but expansion guided by understanding can create harmony even in the most vast and complex spaces. So the sky above is not merely filled with objects, it is filled with intention. Each orbit is a path chosen carefully, each movement part of a larger system that continues to evolve, quietly maintaining balance in a place once thought to be beyond all limit. Invisible traffic light systems exist. Advanced tracking and prediction systems monitor satellite movements and act like traffic signals to prevent accidents. What appears as empty silence above the Earth is, in truth, guided by an intricate system that functions much like traffic lights, though no colors shine and no signals can be seen. These systems exist in the form of continuous tracking, data exchange, and predictive analysis. They watch every satellite, every fragment of debris, and every movement with quiet precision. Nothing is left to chance. Each object in orbit is part of a vast monitored network where position, speed, and trajectory are constantly calculated. This invisible guidance begins with observation. Ground stations and monitoring networks follow satellites as they travel across the sky, gathering data about their exact location and motion. This information is not static, it is updated again and again, forming a living map of orbital activity. Within this map, advanced algorithms work tirelessly, projecting where each object will be in the future. They do not simply see where something is, they anticipate where it is going. From this awareness comes prediction. When two paths begin to draw too close, the system recognizes the potential for danger long before it happens. This moment is the equivalent of a yellow light, an alert that calls for attention. Engineers and operators receive these warnings and begin to assess the situation. They do not rush blindly into action. Instead, they evaluate probabilities, consider timing, and choose the most efficient response. Sometimes no action is needed. The objects may pass safely with enough distance. Other times, a decision is made to adjust a satellite's orbit slightly. This adjustment is small, almost effortless compared to the scale of space, yet it carries great importance. It is the silent equivalent of stopping at a red light or moving forward at green, simple actions that prevent disorder. What makes this system remarkable is that it relies not on physical barriers or visible signals, but on knowledge and coordination. It is a system built on trust in data, on shared understanding, and on the discipline to act only when necessary. In this way, the unseen traffic lights of space reveal a powerful truth. Guidance does not always need to be visible to be effective. Awareness before action. Potential collisions are predicted early, allowing calm, calculated decisions instead of reactive measures. In the vast movement above the Earth, nothing is left to sudden reaction. Every action begins long before it is visible, shaped by awareness that quietly watches and understands. This principle, awareness before action, is what prevents disorder in a place where even the smallest mistake could have lasting consequences. It is not urgency that keeps satellites safe, but clarity. Each object in orbit follows a path defined by speed, altitude, and direction. These paths are not random, they are studied, predicted, and continuously observed. Systems on the ground gather streams of data, updating the position of satellites again and again. This constant awareness creates a living picture of motion, where every trajectory is understood not only in the present moment, but also in the moments to come. From this awareness, insight emerges. When two paths begin to approach one another, the system recognizes the possibility of danger far in advance. There is no panic in this realization. Instead, there is space to think, to evaluate, to decide. The potential for collision is measured carefully, not assumed. Probabilities are calculated, and different outcomes are considered. In many cases, what appears risky at first may resolve naturally as paths shift over time. When action is required, it is taken with precision. A satellite may adjust its course slightly, changing its timing or position just enough to avoid conflict. This movement is not dramatic. It is subtle, controlled, and intentional. Because the decision was made early, the adjustment can remain small. There is no need for forceful correction when awareness has already created room for calm response. This approach reveals a deeper understanding of control. True control does not come from reacting at the last moment. It comes from seeing clearly before action becomes necessary. It is the ability to observe without haste, to understand without fear, and to move only when movement is truly needed. In this quiet discipline, there is a lesson that reaches beyond orbit. When awareness leads, action becomes simple. When observation is steady, decisions become clear. And when clarity guides movement, even the most complex systems can remain in balance. Small adjustments prevent big disasters. Satellites make slight orbital changes when needed, avoiding collisions and maintaining order. In the delicate environment of orbit, safety is rarely achieved through large dramatic actions. Instead, it is preserved through small, precise adjustments, movements so subtle that they might seem insignificant, yet they carry the power to prevent major disasters. A satellite does not need to change its entire path to avoid danger. Often, a slight shift in timing, a minimal change in altitude, or a gentle alteration in direction is enough to create safe distance between two objects moving at immense speed. These adjustments are made possible because risks are identified early. When a potential close approach is detected, there is time to act thoughtfully rather than urgently. Engineers study the situation, calculate the safest option, and command the satellite to perform a maneuver. This maneuver might involve firing a small thruster for a short duration, just enough to nudge the satellite onto a slightly different trajectory. The change may be measured in mere meters or seconds, but in the context of orbital motion, that difference is everything. What makes this approach effective is its restraint. Large movements would consume more fuel, reduce the satellite's lifespan, and potentially create new risks. Small adjustments, however, maintain efficiency while preserving safety. They respect the balance of the system, allowing satellites to continue their missions without unnecessary disruption. It is a form of problem solving that values precision over force. This principle also prevents escalation. A single collision in space could generate thousands of fragments, each becoming a hazard for other satellites. By making minor corrections early, such catastrophic outcomes are avoided entirely. The system remains stable not because it reacts strongly, but because it responds wisely at the right moment. There is a quiet discipline in this method. It teaches that not every problem requires a large solution. Sometimes, the most effective response is the smallest one, applied at the right time with clear understanding. In orbit, these gentle corrections preserve order in a complex and crowded environment, proving that subtle actions, guided by awareness, can protect against even the greatest potential dangers. Global cooperation ensures safety. Countries and organizations share data and responsibility, creating a collective system that keeps space operations safe and sustainable. Beyond the technical systems that track satellites and predict their paths, there is a deeper layer of order in orbit, one built on cooperation, shared responsibility, and mutual awareness. No single nation or organization controls the entire sky above Earth. Instead, space is used collectively, and its safety depends on the willingness of many different groups to share information and act in harmony. Satellites are launched by governments, private companies, and research institutions across the world. Each has its own mission, but all share the same environment. Because of this shared space, coordination becomes essential. Data about satellite positions, movements, and potential risks is exchanged between tracking centers. This exchange allows everyone to maintain a clear understanding of what is happening above the planet at any given moment. When a possible close encounter is detected, communication becomes especially important. One operator may adjust a satellite's path while another monitors the result. These decisions are not made in isolation. They are often the outcome of discussion, analysis, and agreement. In this way, safety in orbit becomes a collective effort, rather than a solitary responsibility. This cooperation extends beyond immediate safety concerns. It also includes long-term planning to reduce congestion and prevent future risks. New satellites are placed with consideration for existing objects, and guidelines are followed to minimize the creation of debris. Even small fragments are tracked whenever possible, because in orbit nothing is truly insignificant. What emerges from this system is a form of global awareness that goes beyond borders. In space, there are no physical divisions, only paths that must be shared carefully. The need for coordination encourages a mindset of caution and respect for the shared environment. This quiet collaboration ensures that orbit remains usable despite its growing complexity. It shows that safety is not achieved by isolation, but by connection. When information is shared and responsibility is distributed, even a crowded sky can remain orderly, allowing technology above Earth to function smoothly and continue supporting life below.